able to. You guys can keep an eye and let me know. All right, using your calculator, graph the parent function y is equal to x squared and complete the table of values. Okay, so let's get it in there. It should be on default, so hopefully everybody reset theirs, but they probably didn't from night period. I'm struggling with that. So y equals x squared. X squared, and you're going to graph it. Okay, and complete the table of values. So we are just going to go to, and that, okay, let's do this. Y, hopefully I have some lead. Y is equal to x squared is the parent function of a quadratic. Okay? It is your parent function of a quadratic. So, and you need to know a terminology that you probably have forgotten. Does anybody remember what that means? Yes? What does it mean? It's an A with two lines on both sides of it. You did it in 6th grade.
We did?
Oh, I remember doing it. I don't remember what it is, but I remember doing it.
Absolute value. Okay? So if you have a number like this, oops, that's a curve, okay, and it is in parentheses, and it is a negative number, the absolute value of -5 is always 5, positive. Okay? All right? The absolute value of any number is always positive. All right? So it means the absolute value of A. Okay? All right. So I'm just going to go to my table, but that's what your parent function looks like. Okay? And we're just going to leave it there. I'm going to go second in table, and I'm going to plug in some points that they want here. -2 is 4. Hopefully we would know how to do this. We would just put in -2 for x and square it, and we would find 4. We'd put -1 in for x, and we would find that that is 1, 0, 0, 1, 4, 2, and, no, 2, 4, sorry. It's 1 and 1, my bad. And then 2 and 4, and remember it's going to be that because you have a mirror image. So here's my vertex. I've got -1 and 1, and I've got 1 and 1, and I've got -2 and 4, and I've got 2, 1, 2, 3, 4. Make sure I did it right. And there is your beautiful parent function. Okay? Now, it will look a little bit wider depending on, or skinnier depending on what you have your windows set at. Hopefully they're on default right now because that's what we want. Okay? Now graph the following functions. All right? One thing you need to know. What we want to do is you always compare changes to the parent function. So, in other words, we are comparing what we do to the parent function y equals x squared. Okay, so that is why under y1 we will still have x squared because we are comparing what we are going to put in to the parent function. We know that that is the y1, okay? All right. So y2, it says to put in 2x squared. Okay? Then it says under y3, it is 5x squared. And sometimes in order to keep, if you just do them in order, it'll help keep them, but you can also do this. This is blue. Some of you don't have one with color to take home, but this is just, if you do, red, and this is black, so that once you look at them, you can see the difference, okay? So, how does the graph of y equals x squared change? Well, let's look at the graph. What do you notice on your calculator? How is the graph changing?
It's, right.
Okay? So how about if we put it in some mathematical terminology?
It's range is there.
As the coefficient of x squared gets larger, the parabola becomes, we're going to use the term narrower. How do you like that word? It stretches vertically away from the x-axis. This is called a vertical stretch. And occurs when the absolute value of A is greater than 1. In other words, AX, okay, you see how we have AX squared up here? Okay, I'm talking about A. Whatever, right now the parent function has a 1, correct, for A? All right, so as your A becomes larger than 1, and that means the absolute value could be a -2, and it's still going to vertically stretch away from the x-axis. Does that make any sense to everybody? Okay, vertical stretch. So look at me. Here's your x-axis. It's horizontal, so it's vertically going away from the x-axis. It is stretching away from the x-axis. Okay? So let's look at the table of values and how they change. So we're going to hit second and table. And under Y1, we already have those down up top. Y2 is 2x squared. So when x is -2, y is 8. When x is -1, y is 2. We're still at 0, 0 for our vertex. Okay, and then we obviously have 2 and 8 here. But when we get to 5x, -2 has a y value of 20. -1 is 5. Our vertex doesn't move, okay? This does not move your vertex. And then you've got 5 and 20, okay? So that is called a vertical stretch. And it could be a -5x, and it would still give you a vertical stretch when the value of the absolute value of A is greater than 1. Okay? Everybody caught up? Okay. All right. I have a note on the side. We're going to write it. Oh, on the second page, I guess, is where I did it. That's good. We'll do that in a minute. We're going to do all this first. Okay. Now graph the following functions. How does the graph of y equals x squared change? So we're going to go back to y equals. We're going to leave our x squared there. And we're going to go to y2. And we are going to put parentheses, 1 divided by 2 parentheses, x squared. And then we are going to... Then we're going to go down and we are going to put parentheses 1 divided by 5 parentheses x squared. And then we are going to take a look at the graph. And you see our parent. Ooh, there's half x squared. And there is 1/5 x squared. So it's the parabola, I want to say, is getting fatter, isn't it? It's getting wider. Okay? So how does the graph of y equals x squared change? As the coefficient of x squared gets smaller, the parabola widens. It compresses towards the x-axis. This is called a vertical compression. Okay? So, if 0, the absolute value of A, essentially what this says is if it's greater than 0 but less than 1, okay, the graph is wider. Now, remember, absolute value is always a positive number. So if you have a negative number, it is still the absolute value. So you could just say if the absolute value is less than 1, the graph is wider, if that confuses you with that terminology there. Okay? Because if it was a negative 2, it would still, negative 1/2, it would still compress and be considered a vertical compression. So let's look at our table and fill in our information. So for 1/2 x squared, I've got 2, I've got 0.5, I've got 0, 0.5, and 2. Okay? And for 1/5, we've got 0.8, 0.2, 0.2, and 0.8. Now, this all has to do with the coefficient, okay, of x squared. 4 on the side. Algebra 1. You will only have vertical compression that equal 1/5, 1/3, or 1/2. I've never seen them be anything different than those 3 values. Okay? In other words, they're not going to give you 5/8 or, something crazy. Okay? If I asked you what's the scale factor of this, what would you say? Yep. So your scale factor is 1/2. Just wanted to make sure you understood what scale factor is. Okay? All right? So dilations have to do with linear, okay? 8th grade math, dilations have to do with linear equations. We are dealing with quadratic equations, which are not linear. Okay? Now the graph for the following, now they want us to do this. So let's go back to y equals. Let's get rid of y2 and y3, and let's go back up to y2 and put in negative x squared and see what happens. Graph it. There's your parent. There's negative x squared. So the negative sign is going to make the parabola open downward. Okay, that's when you have a maximum. Okay, for your vertex. All right, so it's still, so let's see, how does the graph of y equals x squared change? The negative causes the parabola, what? Sorry. The parabola to reflect over the vertex. And it's called a reflection. It's reflecting over the vertex. The parabola, which I know you all can see, opens downward. Okay? So it's called it reflects. Okay? So let's look at the table. And they want the table of values. Negative 2 is negative 4. Negative 1 is negative 1. 0, 0. So we're staying with our vertex there. Negative 1 and negative 4. Okay? And we got one more thing to investigate here. Okay? Now graph the following. Okay? So now we're going to go back to y equals. And this is y equals x squared plus or minus k. Okay? So now we're going to have something other than x squared. All right? So y1 though is going to be x squared because it's plus 0. Okay? So then let's go down and let's get y2 in of x squared plus 5. And then we're going to go to y3, which is x squared minus 5. So we're going to see what a constant does to our quadratic equation, essentially. So let's graph it. There's your parent. There's x squared plus 5. Oh. And then there is x squared minus 5. So what does it do? Can you say that in words?
Makes it go down more. Oh, it changes the minimum.
So, okay, so let's put this in terms that works for both minimums and maximums, okay? Because it could be a negative. So, k, your value of k, shifts the graph vertex up or down. So it's moving your vertex up or down. Your k is moving that graph. Adding to x squared moves the vertex. Uh-oh, didn't spell it right. Vertex up. Subtracting from x squared moves the vertex down. Okay? Yes. Okay. So let's hit second in table and fill in our table value. Coming.
When somebody knocks on this door, it almost gives me a heart attack. This
Does
is the
it?
same class that they always come to get me from. They always come to get me out first period. Anytime somebody knocks on first period door, I'm like,
Okay.
PTSD hits me hard.
Okay. So here we go. So -2 is 9, -1 is 6, 0 and 5, 6 and 9, and then this one is -1, -4, -5, -4, -1. Everybody get that? That's the trash. Okay, so what are the equations of these graphs? We have to figure it out with no information, just looking at it. Okay? Alright? So, I am going to give you, why didn't it copy? Alright, our parent. First, you need to know what your parent is. Okay? Your parent is always 0, 0 at your vertex. Alright? Then it's 1, 1 and -1, 1. So it's 1 and 1 and -1 and 1. So we're going to draw our parent. It is always 2 and 4 and -2 and 4. I did that backwards. So here's my parent. This is, so have we compressed or have we stretched from the parent? Really, this is my parent. Okay, so you've compressed towards the x-axis, right? So let's find a point here, and it's kind of, do you see that this is halfway between these two? Do you see that? And this is crossing at 2. Do you see that? Okay, so if I was to take my new scale factor over my old scale factor, 2 over 4 would give me what? My y values. 2 over 4. Scale factor. What is 2 over 4? Simplified. 1/2. So this one is y equals 1/2 x squared. So I did a scale factor using this from my parent and this from my new, okay, and I've got new over old, and I've got 2 over 4, which gave me 1/2, okay? So now we're going to graph our parent on this one. I've got 0, 0, 1, 1, 2, 4, 1, 2, 3, 4, okay? It would look something like this, okay? So, what's happening here? So this was a compression, right? This is a stretch, right? Okay. This is at 2. This is at 1, 2. This is at 1, 1, 2, 3, 4. Pretty much at 4. It's kind of drawn really badly. This is y equals 2x squared. 4 over 2. New over old. Okay. Alright. Let's see what happens here. I've got 0, 0. I've got 1 and 1. I've got 1 and 1. I got 2 and 1, 2. 1, 2, 3, 4. I got 1, 2, 1, 2, 3, 4. I'm off over here. This is 1, 2, 3, 4 here. All right, there's my parent. So I've obviously have moved it down how much? 2. So I know I'm going to have a negative 2. So y equals, now I have to decide, is it still going over 1, 1? Is to me. 1, 1 is to me. 1, 2 goes up 1, 2, 3, 4. That's working, right? 1, 2, 1, 2, 3, 4. So all that happened here was I had x squared. Okay? You still have the same points. It's just, well, they're not the same points, but they're still spread the same way. You haven't had a stretch or a compression. And then over here, all right, here we go. Let's see. If I go here and I go over 1, down 1, over 1, down 1, over 2, 1, 2, down 1, 2, 3, 4. I'm hitting it, right? 1, 2, 1, 2, 3, 4. So this one is just going to be what? Y equals what? Well, is it x squared? Negative x squared, correct, because it's turned upside down, and then it is plus 2 because it's moved up 2. Okay? Not too bad, right? All right.